Hey there, Russ here. Welcome back to the shop. Well, let's have an OTB thinking here. Um, I've been thinking about having a bench supply. Now, I did make this one here, very nice, but this meter alone costs somewhere between 90 and $100, and it's a little higher than that now. It's going up, and it's very high. It's a very nice unit. Don't get me wrong, and I will not regret buying it. But not everybody can do that. Sometimes you don't need that elaborate amount of power supply for the things, the little projects that you want to do in your shop or in your hobby room, wherever you're doing and whatever it is you're doing. So, um, getting by a little less, but still being able to have a good power supply is kind of nice to have. So I've decided I can make one for under $30 that will run off of a Ryobi battery. But not only will it run off of a Ryobi battery, but I can take and plug this into any DC power source and hook it up to my Ryobi battery on the output, and I can charge Ryobi batteries with it. So not only can I use it as the source of power for my bench power supply, but I can also use this power supply to charge that battery up from another source. So let me show you how that can be a real advantage, especially in a small shop for very little money. So this is the thing I'm talking about right here. And nothing major. It's really very simple. It's based on this meter here that you can get. Now this one in particular is a Drok, D-R-O-K. I have a link to it where I bought it off of Amazon. I originally bought one that was a generic one. It turns out it's bad. It's almost 100% like this one, same specs. The input voltage on this has to be 6 volts up to 36 volts. Anywhere in between, and you have that range at your availability to be able to use it to the output, because this is what you call a buck boost converter. 36 volts is what it puts out, 5 amps, and it's actually very simple to operate. So what you can do is on your input has to be at least 6 volts. So you can hook it up to any power supply, up to a Ryobi battery, anything as long as it's less than 36 volts and more than 6, it can be the power source for this. To put it together, these units have the 5 amp hour type unit. You can also get these things similar, but then they start having their own breakout board. But they had this in a 20 amp, I think a 12 amp or something also. So there's a couple of different versions. The DPS line on the Rydell also has a lot of this type of stuff, but they get up into the $40, $50, $70. Now you're getting close to buying that one right there when you do that. So this was pretty cheap, and it is only 5 amps and 36 volts. But quite frankly, 99 times out of 100, what I'm working on is experimenting with or trying to conceive something. It's usually trying to motivate from using either my lithium 12-volt batteries or from a Ryobi tool battery, which is 20 volts. So 36 volts spans that whole range. So this actually worked very well in the shop. And if I needed a quick power source to test something, see if it's going to work on a Ryobi or on my other lithium battery, I can hook this up real quick. It is adjustable on the volts down to 2 digits, decimal points. And the amps, also it measures, and those, it measures down to the hundreds, to 3 digits. Blah. Anyway, it's a pretty accurate meter, and I tested it. It seems to become up pretty accurate based on my regular meter and a couple other voltmeters that I have around. So I'm very confident that it's actually a pretty accurate unit, the Droks. The one I bought from AliExpress was almost about $12 less, but unfortunately, it didn't work. So maybe it's this one, maybe not. I don't know. I went with the Droks because I've had good success buying Drok stuff and other electronics. And so I do have confidence, but they're usually a little more than a lot of those fly-by-night ones that you can get like off of AliExpress. Those are kind of a crapshoot to get them, and they work. It works for about the first 10 minutes of trying to experiment with it, and then boom, all of a sudden it can't get over 1 amp out of it instead of the 5 amps. So I don't know what happened to it, but anyway, I decided I really wanted to get this going. It's going to be very handy to have, so I went with the Droks. The wiring couldn't be simpler. Again, on the bottom of the unit has an 18 gauge or less is really what you want to put in this of wire. 2 for the input and 2 for the output. So it takes what you put in the way of DC volts, and you can manipulate it using the interface to whatever voltage range and amperage range you want on this. And it'll track watt hours and amp hours. It'll also track the time of while it's running, so you can see real time what it's going on while you're using it. So, and you can control upping and lowering the voltage and the amps on the fly with it. So it's pretty versatile as a power supply and accurate. What more could you ask for? And for under $30, and in such a small footprint in the shop, if you have a very small shop, this is perfect for that sort of thing. You don't need a big bulky one like this that takes up maybe a lot of valuable workbench space. So, but it's a great alternative. So let me show you how it works off of different power sources, and that you'll find that it is it can actually be very useful in a small shop. So if I take it and I want to use it as a Ryobi battery as a power source, I do have a plug-in here. Now, right now this is a prototype. Eventually I will have it built in, the connector, but right now that goes on there, and I'm using this universal connector right here. It has a voltmeter here, it's connected here, and everything comes out onto 2 alligator clips that are marked positive and negative. So I'm just going to slip that onto the end of this now that it's in place, and you can see the light on the meter. It says 19.9 volts. So let's hook this up. Input, this is the input side of the meter. This is the output. So we're going to hook the battery up to the input side, right on those banana clips. And yeah, I'm using the 4mm banana clips as my connectors. And they also can spin out, so you can put another type of connector on there, or just wrap the wire around and tighten it down. So these are nice little clips, and they give you a lot of versatile connectivity. Little alligator clips slip right into the banana clip without any problem, as well as a banana type connector like that. So, and if I have a clip on it like that, alligator clip, it still will clip on there without any problem. So these are handy to have around, and you're going to want some for this sort of thing. Anyway, so now that I'm hooked up, you'll see that it powered up immediately. It's off right now, so there's no power coming out here. But if I want to, I can adjust what power comes out. Right now, it says it's set to 20.2 volts. Means that if I turn this on, it's going to be putting out 20.2 volts out of here. Now, there's only 19.8 volts and 9 volts in it. So it's actually boosting the voltage to take it to 20 volts. If I turn it off, if I wanted to lower that, let's say I can go over my menu to the volts out, and I can preset it here to the, oops, here we go, to the amount I want. We're going to take it down to 12 volts, 12.7. And it takes a few seconds and it'll go back to the menu, so that if I could drive it with the menu then. So now it's gone back. So now I can go back to my my page 1, which is my volts, amps, and watts in real time. So if I started power something, draw power, it would be measuring what's coming out. And if I turn it on, now we're getting 12.4 volts. So if I want to, I can take that, remember how, oh, right here, yeah. I can take that and I can adjust that voltage up or down on the fly if I want. And then eventually it clears At this point now it's at 14 volts instead. It's gone back to the menu. If I go to page 2, that's my another one of my outputs, and it has the amp hours, watt hours, and the time that it's running. So the time I turn it on until I turn it off, that is timing it. So in real time, you'll be able to tell how long it's been running, as well as how much has been drawn out of the power source, if you want, how much has been used. So it's a pretty simple power meter, very accurate. It goes from 36 volts up to 36 volts down to 0.6 volts. So it's got a pretty small voltage output if you want. So you can really get into some pretty fine stuff. Not everything, but a lot of it with a meter like this. So this, for the casual user, this is all you need. And look how small that is. And it's in full use. If I want to hook up to something, I just put 2 banana leads on here, hook them up to whatever I want. Or if that already has adapters on it, for example, I have this fan here, and if I want, I take the positive. Now this thing runs 2.5 volts. Oh, excuse me. Sorry, I had to turn that off. So it's set to 14 volts. So I do want to reset that. So let's set that down. Whoops. And then let it reset up to the menu. That'll clear in a moment. And then after about 5 or 6 seconds. And now when I turn it on, it's running at 12.1 volts. And it's pulling 2.60 milliamps. 2060 milliamps. Running the fan. So it's a quick, easy power source for something under 5 amps. So it's really nice, but that's not all it'll do. If I want to, instead of using it as the power source, I can take it and actually unplug this from the meter, and let's plug this on the output of the unit. So that means that whatever I hook to it will be pushing power into the battery. Now that we're hooked up there, let's get a power source. Here you go. I have a cigarette lighter here. I have a cigarette lighter power source here. I can plug this in, plug it into the wall, 2 banana leads, and I have, this one puts out 12 volts, 10 amps. So that's more than enough power to do what I want to do here if I want to hook it up. Also, if you have one that you just got saved from, you don't know even where it came from, this is a 12 volt, 3 amp. And this one, let me plug this one in, and it's powered up. So I have voltage. This has the barrel connector. And so I just made up a quick test lead barrel connector with alligator clips. Plug that in, negative, to negative, positive to positive, and I power up. And now I'm showing it's off, but I'm showing that I can put out, it's set to, it says I got 20 volts on this side. It does read the voltage right here. If I take this off, that voltage goes away to 0. So this is actually on this side, this meter is reading the output voltage, what's out there at any given moment. If I want to set it right now, if I turn it on, it will give me 12 volts. Well, this is a 20 volt battery. So let's take this, press it again, and then let's go over to, whoops. And let's take this up to 20 volts. Point 2 is what we're going to want. And then now we'll let it reset. And I have it set to 5 amps. We are going to want to change that. So let's go back in. Whoop. Go to the 5 amp. And I'm going to change this to 3. Now that it's set up, we'll leave it setting and let it go. And now, when I turn it on, I am actually pushing. Now, since this battery is almost full, it's not going to push more than the 3 amps, obviously. But it also is not going to push. Right now, it's only pushing 1 amp into it, and it's dropping off because this battery is already almost charged. But it's charging this battery now from this power supply through this into that Ryobi battery. So now this is this is a battery charger for either lithium batteries, like I have right here. This is my 100 amp hour power station. I could plug theoretically this thing and hook it up there, and it would push up to 3 amps in this case. But depending upon the power unit I use, with this meter, I can put up to 5 amps into that, charging even that battery. So it's a battery charger as well as a power, a PSU. So, and like I say, it keeps a narrow footprint. It's very handy because I do use my batteries, my tool batteries a lot for a lot of things I do. So this gives me a quick, easy way of doing it. So now it's dropped off to 0.9 amps. So it's slowly filling that up. And I imagine that when I get done, if I turn it off, and take this off, come on. Let me unplug that so we don't have any power there. And now if we check the battery, it still shows 19.9, but it has put a certain amount of charge into this battery during that time that I had it hooked up. So so now I can use this thing either from any power supply AC unit, or I can run it off of my 100 amp hour battery power pack, simply with this plugged into the power unit back here and plug that into there, or I can run it off of any DC power source. I also have an ATX breakout box that I've set up on my workstation right here. If you remember a while back, I showed this to you right here. This is an ATX. And right now I'm using this 5 amp buck boost connector, but it has these knobs on it. I'm definitely going to switch this out for one of those because that meter is a little better. I like that meter better than that one, but I'm still looking. And if I can find a better unit than this, that'd be even better. But so far in a buck boost converter, 5 amps is about as good as I can find as a normal apparatus. Anyway, I think that's about it. You can see it's very simple, and I need to go over some of these things that I've made, these little tools, like my gauge that fits on the Ryobi battery, same as this one. This one I used a factory-made unit that I got off of AliExpress, and I talked about these in the past. This one was shop-made. I made this one myself with just the Ryobi clip, and it works the same way. There's the voltage. I have access right here to be able to hook it up to anything I want. So I've got a bunch of different tools that I've done that with, and I want to go over some of that stuff and show you some of the tricks that I'm using in my shop, in my electrical workshop area, because I've added some nice features to some of the things that went on. I also still owe you guys a video on my year end, and hopefully I'll do that here in the next few days. So I have several videos I kind of like to do, but I'm just curious. Don't be afraid. Why don't you guys tell me what you're working on? A lot of times I hear what you're doing, and that ends up being my next OTB project. So you never know. I'm always interested in what you're doing when you're not in front of a camera or on YouTube watching my videos. So don't be afraid to share. I'd love to hear it. And like I said, it might even lead to another OTB moment. You never know. So stay tuned. If you have any questions about this, about how to make it, let me know. As I said earlier, it's real easy to make. Once you hook up the 2 banana clips to the in and the output to the banana clips, I used a inline fuse on the intake part, on the input part, so that it has a 5 amp fuse protection. And that's all there is to it. So 4 wires one fuse, and the meter. And then I boxed it in. This is so that this will set down on here. I'm probably going to make my own shop-made one that'll be in here stationary in this thing, so that when I put the battery in, it'll automatically engage. And then it'll have two leads out of it that I can either hook here or here real quick. Or hook it directly to something if I want to for some reason, to bypass the meter. So it'll make a quick, easy box to be able to adapt any Ryobi battery to get quick access to its power, either through controlled meter or directly if you want from this unit. And it does a lot of other things too, like I said. So look through your old junkies. You may find one of these that you might want to keep with that, so that when you use that, you have a nice little power supply to go with it. This is a nice long cord, so this is probably going to end up with that. So I'm probably going to have to remake this. And I think I'll make it slightly bigger, so I have a place to store the power cord and maybe a set of leads in the box area. And I think I'll have the battery turn upside down and drop into the box instead of setting this on top. So this has definitely got to be redone. But I wanted to show you what I got and what you can do with it. And once you start playing with it, all of a sudden you find all these other uses for it. So it's handy. 5 amps, 36 volts. It's not a bad power supply to have on hand, especially for under 30 bucks. So anyway, any questions, any thoughts, any projects you're working on? I'd love to hear from you. If you learned something here, you like this video, hit that like button. Lets me know I'm doing something right. Most importantly, though, come back again, because I'm nowhere done around here. Thanks, and we'll see you guys again very soon.